This is lesson 6.3, compound and continuous interest. So a common application of exponential growth is compound interest. Compound interest is interest paid on both the initial investment, called the principal, and on previously earned interest. So the formula looks like this. A, which is the total balance, is equal to P, which is the principal or initial amount, times 1, plus R, which is the rate, over n, so the number of times compounded yearly, to the power of n times t. So let's work through some examples with this. Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years if the interest is compounded with the following frequencies. So semi-annually. Semi-annually means twice a year. So right here, twice a year, 2 times a year. So the total balance A is equal to the initial amount. He invests $300 in the account, so 300 is the initial amount, times 1 plus R. R is the rate, as a 5% interest rate. 0.5. The percent written as a decimal is 0.5. (0.05) over 2, because it's being compounded twice a year. We're raising this to the power of n times time. So n is 2 times time, 15 years. This is 300 plus 1.025 to the power of 30. And that equals $629.27. Now it's asking with a monthly frequency. So this means that n equals 12. There's 12 months in 1 year. So A equals the initial amount, 300, times 1 plus 0.05, because it's still the same interest rate, and we're dividing this over 12 now. And then we're taking it to the power of 12 times 15. So that's 300 times 1.00416 to the power of 180. And that equals $634.11. So for the second example, if $2,500 is deposited into a savings account earning 8% annual interest, how much will be in the account at the end of 25 years if the interest is compounded with the following frequencies? So A equals the initial amount, which is $2,500, multiplied by 1 plus the rate, which is 8%, so 0.08, over, and quarterly is 4 times a year, so over 4 to the power of n times to the power of 4 times 25, because it's asking for 25 years. So 2,500 times 1.02 to the power of 100 equals $18,111.62. Now it's asking for a daily frequency. So there's 365 days in a year, so n equals 365. A equals 2,500 times 1 plus 0.08 over 365 to the power of 365 times 25. So 2,500 multiplied by 1.000219 to the power of 9,125. That equals $18,468.50. Next is continuous compounding interest. In some cases, interest is compounding continuously, meaning the account is constantly earning interest. The formula below can be used to find the balance of the account in this case. So A is the final amount equals P, the initial amount, times E to the power of R times time. Now E should be a value on your calculator, but if not, E is roughly 2.718. So I'll put that here. Now, suppose $800 is invested in an account at a 6% interest rate compounded continuously. If no other withdrawals or deposits are made, find the balance in the account after 20 years. So A, our final amount, is going to be equal to P, the initial amount, which is $800. We're raising this to the rate, which is 6%, 0.06 times the time, which is 20 years. So 800e to the power of 1.2 is equal to 26 is equal to $2,656.09. Next, we'll find the balance of an account after 5 years if $1,200 is initially invested at an interest rate of 12.5% per year, compounded continuously, and there are no other deposits or withdrawals. The final amount is equal to 1,200 times E to the power of 12.5%. 12.5% as a rate is 0.125 multiplied by 5 because they're asking for 5 years. And this is 1,200 times E to the power of 0.625. And A equals $2,241.90.